All right, here's 8-1, day 2. Short lesson on a very specific topic. It's called Row Echelon Form. And basically here is the deal. In the first day, we talked about the elementary row operations, which we're not going to practice again. Okay, well, in the third day, we'll get back to those. You can interchange rows in a matrix, you can multiply by a non-zero constant, and you can add a multiple of one row to another. Those are the three things that we can do. If we're specifically solving a system of equations, which is the primary thing that we're going to use matrices to do, at least in terms of the row operations, row echelon form is like the end result that we're after. Okay, it's what we're trying to get to, right? There's a certain form that we want to get that matrix to that we know we're done with the row operations. Okay, so a few things that we're looking for to say that we're in row echelon form. If we have a row of all zeros, it's got to be at the bottom. Okay, for each row that's not all zeros, the first non-zero entry needs to be a 1. Okay, we call those leading ones. And then for successive rows, assuming that they're not, not a row of all zeros, the leading one, as you go up, should be farther to the left. As you go down, it should be farther to the right. You should see kind of this diagonal of ones that starts from the top left and works its way down diagonally. Okay? It's going to require some examples to see. Reduced row echelon form is where it's in row echelon, but then every leading one has a 0 on top and on bottom. Okay? Now, the definition is great, which I want you to have, but it's very possible that you see those and you're like, sure, okay, no idea what you're talking about, but whatever. And that's not the biggest piece. The next few slides have examples. This is really one of those cases, do you know row echelon form if you see it? Okay? There's no row of all zeros. Okay, so I'm not worried about that. We have a bunch of what we call leading ones. Okay, and notice how they form this diagonal, and every one that you go down is farther to the right. Or as the definition says, as you go up a row, the leading ones are farther to the left. Okay, and you can see that you kind of get this diagonal of leading ones that form. Okay? So for that one, I'm going to say it's in row echelon form. But notice right here, see how that 2 is above the 1? I'm not going to say it's reduced because all my leading ones have to have zeros above it and below it. And right there, I have a leading 1 that has a 2 above it. So it's not reduced. Okay? That's what row echelon form looks like. For part B, so when I say neither, the direction said to identify if it's in row echelon or reduced, or neither. But if it's neither, we have to say why. Notice there's a row of all zeros. That has to be down at the bottom, okay? Now, it's a good point to bring up here. Can't we interchange the rows? Now, we're not going to work with this matrix, but if we wanted, couldn't we interchange those two rows and put the row of zeros at the bottom? And the answer is yes. And when we get to actually doing more with the row operations, that's the exact kind of thing that we would do, right? Because remember, this row echelon form like we see in Part A, that's what we're trying to get to when we do the row operations. All right, let's look at a few more. Part C, I don't see any row of all zeros. There's a leading 1. Now if you want to start up at the top, and we're checking the leading 1s, as we go down, the next one just has to be farther to the right. So the next row has a leading 1, and it's farther to the right. Same. Okay, so at this point I feel comfortable saying that matrix is in row echelon form. Is it reduced? Well, check out your leading 1s. They, in the column that they're in, there has to be nothing but zeros above them and below them. Okay, and now if it's in row echelon form, there's going to be zeros below them, so it really comes down to, with those leading 1s, are there nothing but zeros above them? And you can see for 2 of them, the answer is no. There's not zeros above them, so I'm not going to say it's reduced. Part D. Leading 1, leading 1, leading 1. There is a row of zeros, but it's at the bottom. Let's call it row echelon form. Dare we call it reduced? Nothing but zeros. Nothing but zeros, other than the leading 1, obviously. Nothing but zeros. Yes, we shall. That's what reduced row echelon form looks like. Okay? As a quick side note, it's good to be able to identify it, but when we could do our row operations to get all the way to reduced echelon form, but you're going to see in day 3 we typically won't. It's really sufficient for us as we do those operations to get to row echelon form and then to say at that point we're good. This will make more sense in day 3, but at that point we've done what we've needed to do. So we don't often simplify all the way to reduced, though we could, but we typically don't. All right, last 2. And if you're getting the hang of these, again, as always is the case, feel free to pause and, work ahead, and then the notes kind of become like a homework assignment, and you can use the rest of the lesson when you hit resume as, an answer key to see if you did it right. Neither. Got to state a reason why. I'm looking right here. Row 2 doesn't have a leading 1, right? As I went in from the left side and I got to a non-zero digit, the first one I come across is 2, okay? It's to the right of the top row, so that's good, all right? Now, we're not really diving into the row operations, but I want to keep making these connections. When you see that, I want you to still be thinking about those row operations. We have a leading 2, if you will. Couldn't we multiply that by 1/2 and make it a leading 1? Yeah, that's, as we're working with matrices, that's exactly what we would want to do. If we had that, we're like, all right, we want to get to row echelon form. We don't have a leading 1, but if we took row 2 and multiplied it by 1/2, we would get a leading 1. So we would want to do that. All right, F, last one. Got a row of all zeros, but it's at the bottom. This is kind of interesting. Here, there's a leading 1. I was kind of expecting it to be in the top left. It's not. But the bottom line is I go down to the next row, and that one was farther to the right. And that top row, that technically is a leading 1, so I guess that 0 is not really a problem. It's a little weird, but I can still say it's in row echelon form. There's nothing in this matrix that violates the criteria. In fact, I see 2 leading 1s and nothing but zeros below it, nothing but zeros above and below it. This is kind of a sneaky one. That one's actually in reduced row echelon form. Okay, fits all 3 of the criteria to be in row echelon form, and those leading 1s, they have nothing but zeros above them and below them.